Most applications store some data in between sessions. It will be bad user experience if we force user to log in every time he launches the app. So we need to store some kind of session key or user credentials inside our app or other data. So we're using user defaults or keychain or files on the flash for that. We also are using some kind of API, most likely, and in some cases there are some authentication required, so we store also some keys. Sometimes they are just plain text strings inside our code. And what else can be stolen from us? This is something big because it involves money. When we implement in-app purchases, we can get cheated by users. And probably there are many, many more issues, but these are the ones that I will cover in this presentation. But you can think that we're on iOS, this land of fairies and unicorns and rainbows, everything is fine. We have fair play, which protects us. Every app is launched in the sandbox, so nothing bad can happen, right? But as Kamil said, it's not that easy. It's much worse, because on the dark side, some users don't like the idea that Apple ships their phones very strictly locked, so they cannot do anything they want, so they jailbreak them. So this allows root access to the phone for users. This is also used by attackers to get our app from the phone and start fiddling with it. So what potential crackers are using to get our app? When we download the app from the App Store, it's encrypted and it's stored on the flash in encrypted form, so it's quite hard to get anything from it. But when the system runs the application, it needs to decrypt it. So Clutch is the tool which runs the application, dumps the memory of an encrypted application, writes the binary, and this is the starting point for the attack. Then you can start reverse engineering it. Then, if you have this unencrypted binary, you can attach a GDB. This is pretty old school way, but from time to time all of us do it. So as we are debugging, sometimes we use the GDB console. There is also other tool called Cycrypt. This one is used in a bit modern way. This is a bit extended GDB, so it has some a different syntax to access everything. But when we think about it, it's still quite hard because we don't know what to find, where to search for it. It would be nice to get every symbol that is inside the app and get it in a list. There is also an app for that. It's Class Dump. It works also on the unencrypted binary. It goes through the binary and finds all the classes, protocols, categories, properties, method names. So then it parses it and generates header files. So you can find every class that is used in the code. So that with Cycrypt is a very good starting point to finding weak spots of our apps. But by default, in release builds, symbols are stripped. So you can ask yourself why those symbols, although class names, method names, are still inside. This is the way the Objective-C runtime was built. It has very neat features with dynamic binding, reflection, and all those goodies. but it comes at a price. When you use at selector expression, in the runtime, system needs to know where to find a part of the code to run after this action is fired. So this is the runtime feature, so it's highly readable for even for human, and we cannot do much about it. But there are also some other tools. To note is Snoopit and IDA Pro. This allows even further spoofing, because some applications require a specific location to run. Let's say we have some streaming service which runs only in US. If the validation is done on the client side, it can be easily spoofed by one of these. It can set location to anywhere you want. And there is also mobile substrate. This is the application which allows to patch our binaries, so create workarounds which bypasses our security checks, disable login, enable premium content without purchasing it. So I was talking a lot about jailbroken devices. This is the biggest problem, and it would be good to know whether the device was jailbroken. Maybe then we can launch it in some kind of demo mode, disable all the premium content. So how to do it? Jailbroken device doesn't say, "Hey, I am jailbroken device, it's me." We have to find a way to do it. Normally, when you launch the app, you don't have the access to shell. So you can try to run shell and see what happens. But with mobile substrate, you can bypass that, unfortunately. So maybe you can find some jailbreak specific files like CDR or mobile substrate. This also can be patched by mobile substrate, so it won't work. So maybe we can try to fork our process and see what happens. Normally it will fail, but in jailbroken device it can succeed. But in some cases this check won't work. There are some materials that say that this check is not working. So if it comes to jailbreak detection, it's really hard to do that, because anything we can think of sooner or later will be patched by crackers. So it's good to check that, but it's not really reliable. And this is the part where you get the money, and sometimes big money, because when we are implementing in-app purchases, either these are some consumables inside the game or non-consumables unlocking premium content, so we want to get money from that. That's why we're doing it. So if user has a jailbroken device, it can easily bypass StoreKit and spoof all the calls saying, great, everything went fine, you can unlock the content. So we need to find the other way to validate if the purchase was really made. With each purchase we get receipt data from App Store, which contains the product identifiers, some additional user info, which can be then validated externally. Normally you do that on your backend, so you send the receipt, and the backend talks to App Store and verifies the purchase. But this can be problematic at some point. I will talk about this a bit later. There is a receipt validation programming guide on the Apple documentation site, so you can check it. It's really simple. Now we get to the obfuscation part. So normally in C++ apps, so you can use obfuscation on the control flow level. So you can introduce additional branching, which does really nothing, additional loops, which don't do anything. You can flatten the call hierarchy. You can substitute the instructions. So there's a lot to do to make crackers work much harder. There is an open source project for that. It's LLVM obfuscator. It's still developed, so not all of the features are implemented, but the team is working on them. But what about symbols? I've said earlier that the symbols need to be inside the binary just for the runtime to know how to work. So what can we do about that? So if let's say we have a method isDevice jailbroken, we could say that we name it differently, but we don't want that in our code because it's less readable. So maybe let's put a define, which will change the name. This is really simple, but then we start thinking we have a lot of classes, a lot of methods, and then we have to find different identifiers, watch out for the conflicts, a lot of work. But there is an app for that. There is an iOS class guard. This is the symbol obfuscator. It also works on the compiled binary, so it extracts all the symbols just like ClassDump does. And this is, in fact, a fork of ClassDump, and then generates for each symbol unique identifier, which is then put inside a header file, which is added to precompiled header. So the attacker gets only randomly generated symbols. So it's much harder to read the app. What else can you do? So I've been talking about the user data, which is stored in between sessions. So you probably want to encrypt it, even when you're storing that in the keychain, which also can be quite easily extracted. You want to encrypt it in some way. You also would like to hide all the API keys and API secrets, which are normally stored as plain strings with some kind of encryption to make it harder to guess and get unauthorized access to our API. Most of the apps which I was showing for the Crackers toolset are using debuggers, so you could also deny attaching to the process. And also you could perform integrity checks to know whether your app was tampered or not. So now, what should you think about when you're trying to protect your app? First thing is performance. For example, if you're using LLVM obfuscator, if it puts a for loop which iterates over a few hundred times and doing nothing, it will affect your performance. And then it's not the same code you wrote, so there can be some problems which are not easy to recreate. If you use symbol renaming, then you could encounter a problem that you get a crash dump from some service or users in production, and you get all these randomly generated symbols, and you'll spend time recreating all those classes and methods to find a problem. Also, you should, when you're doing the receive validation, you should think, what will happen when backend cannot connect to App Store? User probably paid for the product, but you cannot verify that. What to do then? Maybe you should be probably ready to get some refund requests from angry users, but if you want to protect your money, then probably this is the only way to do it. And if you're short on time, you should also think about how much work does it take to implement any of these solutions. Some of them are quite cheap to implement, but some of them will require additional work, additional testing. Maybe you don't have time for that. And the real question is, do I really need it? Should every app be protected 100% from top to bottom? This is a hard question, and I don't think there is one answer for that. Because when you're doing, let's say, some simple blog feed, when you're not storing any sensitive data, then probably it won't be very bad if you don't use any of these techniques. But if you're dealing with real money of people, then the question is not if, but how much do you want to spend to protect it? It really depends on the case, because whenever you're going with the protection level higher, it costs much more, and it can even break user experience when you try to introduce some DRMs. There are many stories about game releases which on the first day servers which authenticate die, and this are recently from Ubisoft or Blizzard. It happens for all companies, so you need to decide whether you want to have a secure system or you agree to some vulnerabilities and get better user experience.